Every day, you are waking up and finding out about a new AI tool that has just been released. And the top 5 AI tools have been garnering hundreds of millions of visits to their websites per month. And it's not just the emergence of new tools that are happening at a staggering rate, even the development of existing tools has been happening at breakneck speeds. Claude released multiple versions of its Claude 3 family of AI models, including the Claude 3.5 Sonnet and the 3.7 Sonnet, all within the same year. OpenAI just released its Agentic Framework Development Kit, so if you were considering learning Creo AI, LangChain, LangGraph, or Microsoft's AutoGen, now you have more options to consider. You have all of these new tools and improvements flooding the market every day, and it's just a lot to keep up with.
It's too much.
And what's scarier is that companies are expecting you to be well versed in all of these AI tools, because it's either you with the knowledge of AI that's going to be working for these companies, or you're going to be replaced by AI. 71% of all companies use generative AI in one form or the other in 2024, which was up from only 33% in 2023. Dario Amodei thinks that 90% of all code written is going to be written by AI in just 3 to 6 months, and that number may jump up to 100% in a year.
We're doomed.
Now, that statement may seem hyperbolic, but this guy is also the CEO of the company that, in my opinion, produces the best code writing AI model. Now, all of these updates are very overwhelming if you're somebody who's technical, who's just trying to keep up, or if you're somebody who wants to get into the field of AI development.
Well, where do I start?
In this video, I'm going to talk about the approach you need to be taking in order to become AI proficient without becoming overwhelmed with the onset of all of these new technologies. Hello, I'm Rashad. I've been a software engineer for over 6 years now, working across startups and big tech, and I'm also the founder for Kaja Labs, a platform that uses AI to teach you anything to get hired anywhere. Before I talk about some of the tools that you need to be paying attention to, I am going to invite you to go to the basics. Because whenever you're building anything, whether or not you're using AI to do it, it should always be as simple as possible. Because complexity is the enemy of maintainability and rapid iteration. So let's break it down. For any generative AI tool, which by the way includes code generating tools, AI agents, which are white hot in the market right now, when you shed all of the layers and see it in its simplest form, it is simply an AI model with a prompt and a response. And this is the fundamental building block. And this is the level of abstraction that we're going to be working with in this video.
You're a victim of theoretical abstraction.
This AI model abstraction can be a simple API call to OpenAI's or Anthropic's APIs, which by the way is the vast majority of AI tools these days. They are just wrappers. This AI model abstraction can be a lightweight AI model that is running on your laptop's CPU or on your phone's microprocessor. Or this AI model can be an open source AI model that you fine-tuned using your own custom dataset and have then deployed on AWS and are exposing via SageMaker API endpoint. It doesn't really matter because all of that is DevOps and system design using software engineering principles that are very well known and have been used many times in the past. So let's come back to our simple building block, and we're going to use this building block to build very complex and powerful AI applications using Anthropic's own blog post, which is a guide on how to build effective AI agents.
Let's begin, shall we?
Spoiler alert, most of these tools that we're going to learn to build are actually workflows and not agents, which is perfectly fine. Most applications can be served very well using a workflow. No need to make things more complicated than they need to be. First workflow type, nice and simple, is prompt chaining. You prompt an AI model to generate a response. Then you take this first response and add a second prompt to this response to generate a second response. Then you may even have a third prompt to add to the second response to generate a third response, and so on. The benefit of this workflow is instead of you having to come up with all of the context by yourself in the beginning, you are getting the AI's help to add to the context for successive prompts. For example, if you're trying to write a research paper on global warming for high school students, the first thing you could prompt the AI model is, give me an outline of all the topics I should talk about. In the second prompt, you could ask it to take that outline and elaborate on each of the topics. And in the third prompt, you could take that elaboration and ask it to adjust the tone so that it fits a high school level audience. The second workflow type is the routing type. A routing AI model will take a prompt and then determine which type of AI model it should be calling next in the chain. And one of these next routes may just be an AI model that is a prompt chain. You see how these building blocks can be used to build on top of one another? For example, if the prompt is a customer complaint, the routing AI model may decide if it's a billing issue, or if it's a product quality issue, or if it's an issue for the returns and refunds department. A routing AI model can even help you save resources by directing easy questions to a lightweight, smaller model and directing harder questions to a larger, more expensive model. The third type of workflow is the parallelization workflow. Let's say you take that same essay on global warming, but now you want to write it not just for a high school level audience, but you want to write it for a college graduate level audience, a PhD level audience, and a fifth grade level audience. A parallelization workflow model can take that output essay and start off 4 separate tasks that run in parallel simultaneously, generating 4 different versions of these essays for 4 different audience members. Now, the only benefit you get out of this is speed. You could have gotten a single AI model to generate each of these essays in turn in sequence. But in the world of AI and software, speed can be the difference between market adoption and being dead on arrival.
Okay, then we gotta go fast.
But also keep in mind that not all tasks can be parallelized. For example, the outlining of the essay and then filling up that outline need to happen one after the other. Okay, so these next 2 models are interesting because we are approaching the complexity of AI agents with these 2 models. First of all, we have the orchestrator worker model. You have a central, highly capable orchestrator model, which takes a complicated task and breaks it down into many subtasks. It then assigns these subtasks to different worker LLM models depending on the kind of subtasks these are. These worker LLMs complete their tasks and then provide the result back to the orchestrator LLM that synthesize the results and present to you in a nice packaged format. If this kind of workflow sounds familiar to you, that's because this is basically the foundation for deep research. You are gathering information from multiple different sources, synthesizing them, and presenting it in a final polished format. And finally, you have the evaluator optimizer model, where you have an LLM generating a response, and then you have an evaluator that continuously provides feedback on that response so that it can be iteratively improved. An example of this can be literary translation. For example, if you're trying to translate a body of text from English to Bengali, the first translation that an AI model is going to come up with is not going to be perfect. You're going to have to teach it on the nuances it should pay attention to. And the more you keep doing this, the better and better the translation is going to get. Before we get into talking about AI agents, there's one more secret ingredient I want to talk about that can enhance your AI tools and applications.
Chemical X.
And that is giving your AI models memory. Memory to enhance the context. Giving your AI tools memory will help them to remember past interactions so that they can help you in the future better. Now, there's 2 ways you can add long-term memory to your AI tools. You can have a simple database integration that lets your AI model search for exact matches based on some criteria. You can also incorporate semantic or meaning-based search, which doesn't give you an exact match for a given criteria, but it returns a list of top-ranking results. And the way you find this fuzzy ranked list of results in semantic search is by doing a cosine similarity on the vector representations of the data you're searching over. Basically, what this means is the machine stores all of the data in a format that it understands very well so that it can return to you a ranked list of the data it thinks you're looking for without you having to explicitly tell it what it is that you're looking for. All of this falls under retrieval augmented generation, and it improves your AI's ability to serve you by referring to external sources in addition to its own trained knowledge to give you the perfect response. So as an example, let's imagine you're trying to build a therapy bot. The moment a user logs in, all of their patient metadata is pulled up by the AI from an external database, and now it is part of the context. Let's say the patient then asks the AI bot to pull up the notes from last Monday. This is an exact search, and the AI bot can look at an external database to pull up all of the records from that particular date. Then the user may tell the therapy bot that now I want to talk about all of the times in the last year that I've talked about traveling. This is going to kick off a semantic search because the machine is going to go over everything it has stored that it thinks is related to traveling. An AI agent is built with the very same building blocks that we've discussed today. It's a collection of very specialized AI models and tools working together with software engineering integration. For example, an AI agent may have a software engineering integration that lets it do web searches real time. An AI agent may also have a software engineering integration that lets it browse files on your computer while at the same time using an AI model to interpret the folder tree and the file structure to figure out what it's looking at. Now, there are a lot of frameworks that let you develop agentic AI, for example, LangChain, LangGraph, Crew AI, Microsoft's AutoGen, and more recently, OpenAI's Agent Framework. And more important than specializing in learning one of these frameworks is perhaps understanding the building blocks that are available to you and what it is that you're trying to build. Because there are also a lot of no-code tools that let you put together AI agents, and specializing in any one of these is not going to be your competitive advantage. Your advantage is going to be able to take a big idea and decompose it into smaller pieces and then figure out which AI building blocks you can use to build that idea up. I hope this gives you an idea about the learning approach you can take to master AI without getting overwhelmed. If this content was helpful, please smash that like button, hit subscribe, and the bell icon notification, and I will see you in the next video.